In this video, I will discuss a JEE Advanced PYQ from the topic Electrostatics. This question is based on Gauss law and Shell theorem. Gauss law relates the electric flux coming out of a closed surface. This is a closed surface, yes, and there can be some charge inside. The electric field here we see. So the electric flux that's coming out of the closed surface, that is integral E dot ds over the closed surface is related to the total charge which is present inside. That's Qn by epsilon naught. Next is Shell theorem. If you have a shell of charge, shell is a spherical surface of very small thickness, like the surface of a football. So this thickness is very small, and there is charge distributed on the surface, say sigma, surface charge density. So the units will be coulomb per meter square, and sigma is uniform charge. Sigma here is same, sigma here is same, everywhere it is same. So for this shell, to find electric field at the point outside, we can assume as if the full charge is concentrated as a point charge in the middle. So for points outside, where R is the radius of this shell, the electric field is given as 1 by 4 pi epsilon naught, that's K, into the total charge of the shell, Q by the distance square, R square. This for R greater than R, that's outside of the shell. For inside shell, the electric field is 0. For R less than capital R. So this is Shell theorem. But the important condition is the sigma should be uniform throughout the surface. Now using this Shell theorem, we can also get one more result for a spherical charge. So this is a sphere where charge is distributed inside. Volume charge is rho, and the unit of rho will be coulomb per meter cube. This is surface charge density, coulomb per meter square. So for this also, electric field outside, it's as if the full charge is concentrated at the center. And electric field at point inside, for that, the charge which is present inside this radius, so this is the inner charge. So only this inner charge will contribute to the electric field at this point. Using the Shell theorem, for this point, these shells which are here, the electric field due to this shell will be 0. But these shells, which as the shell is considered a point charge in the middle. This volume charge can be considered as a lot of shells kept on top of each other. So for this point, all these shells are outside. So these shells will contribute 0 electric field at this point, and these shells here, this point is outside of the shell. So all these shells will contribute as a point charge located at the center. So all this inside charge makes it a point charge in the middle, and that electric field we can find out using the inner charge. So with this understanding, we can solve this JEE Advanced question. The question, in the figure, the inner shaded region A represents a sphere of radius RA equal to 1, within which the electrostatic charge density varies with the radial distance R from the center as rho A equal to K into R, where K is positive. In spherical shell B of outer radius RB, the electrostatic charge density varies as rho B equal to 2K by R. Assume the dimensions are taken care of, all physical quantities are in their SI units. Which of the following statements are correct? Option A, if RB equal to root 3 by 2, then electric field is 0 everywhere outside B. If RB equal to 3 by 2, electric potential just outside B is K by epsilon naught. If RB equal to 2, total charge of the configuration is 15 pi K. Option D, if RB equal to 5 by 2, then magnitude of electric field just outside B is 13 pi K by epsilon naught. You can pause and attempt this question. So, to find the charge, total charge inside this inner sphere QA, what you have to do is take a thin spherical shell of thickness dr at a distance r from the center. So, volume of the shell is 4 pi r square dr, and the volume charge inside this one will be rho. So, this is the charge in the shell. So, if I indicate this thing from r equal to 0 to r equal to Ra, that will give the total charge from here to here. That is charge in this inner sphere. This is another way of getting the total charge. Rho is Kr, so 4 pi K constants, and R cube, indication is R is over 4 by 4, and the limits are 0 and Ra, which is 1. So this is pi K. So the total charge in this inner sphere is pi K. And for the outer shell, this is the shell region from here to here. That is from radius Ra to Rb. To get the charge in that region, QB is same way, 4 pi r square dr is the volume of the shell here, and the charge density is rho b, this is rho a, and integrate from Ra to Rb, because the shell is from Ra to Rb here. And rho b is 2K by R. So this will become 4 or 8 pi K 8 pi 4 pi into 2 is 8 pi K, and then R dr. If you integrate, you get R square by 2. Within the limits, Ra is 1 and Rb is a variable. So this will become 4 pi K into Rb square minus 1. So now we have to check the options. Option A, Rb equal to root 3 by 2. So in that case, the charge inside the shell B QB is 4 pi K into Rb square is 3 by 2 minus 1, that will be half. So this is equal to 2 pi K. So you have to find out the electric field just outside B, everywhere outside B. So electric field everywhere outside B. This is the inner this thing. This is the outer. So this is RA. This is RB. So for any point outside, the total charge will contribute to this electric field at this point. So the field here will be 0 if the total charge is 0. Qa is pi k and this is 2 pi k. So the total charge is 3 pi k. So option E is not true. The only way the electric field here can be 0 is this whole thing can be made as a point charge here and this point charge should be 0. Here this charge here is pi k and the charge in this shell is 2 pi k. So total charge is 3 pi k in the middle. So there will be an electric field here. So option E is not true. Option B, RB equal to 3 by 2. Then the electric potential just outside B is potential outside B. RB equal to 3 by 2. I'll just use these two results. I can remove that. So the charge inside the inner sphere is this one, and charge in the shell is this much. I just need the two results. Option B, RB equal to 3 by 2. In that case, QB is 4 pi k into RB square, that's 9 by 4 minus 1. So this is 5 by 4. So 4 and 4 will cancel. So 5 pi k is the charge in the shell. And inner sphere has got charge. So the total charge is pi k plus 5 pi k, that is 6 pi k. So the potential outside, the whole thing has to be made as a point charge here. So potential just outside this thing, that is potential at B plus, it's K 1 by 4 pi epsilon naught into the charge as a point charge in the middle will be 6 pi k, and the distance is RB, which is 3 by 2. So this 2, make this thing 2, and then this 3 into 2. So numbers will cancel. So potential will be pi also will cancel. K by epsilon naught. So option B is true because potential just outside B is K by epsilon naught. So option B is true. Option C, RB is 2. Then the total charge of the configuration is. In this case, QB is charge in the shell 4 pi k into RB square is 4 square minus 1. Sorry, R 4 minus 1 is 3. So it's 12 pi k. So the total charge is QA plus this one, so 13 pi k. There is 15 pi k there. So option C is not true. Option C is false. Option D, RB equal to 5 by 2. Option D. Then find the magnitude of electric field just outside B. 5 by 2. RB is 5 by 2 for option B. So here QB is 4 pi k into square is 25 by 4 minus 1. That is, I can take this 4 inside. So 25 minus 4 will be 21. So total charge for option D is 22 pi k. So you have to find electric field just outside B. So that is electric field at B plus means just outside B. So it's like a point charge, this one. So 1 by 4 pi epsilon naught. The point charge is 22 pi k by the distance square. That is RB square. That is 25 by 4. So that's equal to pi and pi will cancel. 4 and 4 will cancel. So 22 by 25 k by epsilon. Option D is not correct. So the only correct option is option B. D is also not correct. So option D, it's 22 by 25 k by epsilon naught. First option, the total charge is 3 pi k. So this what I explained here. The charge in the inner sphere QA is integral 4 pi r square dr. This is the volume of the shell. This is the charge of the shell is the charge of the shell. So that is indicated from 0 to Ra, which is 1. And rho A of the inner sphere is Kr. That's given in the question. And Ra is 1. So this integration is R cube. So R is 4 by 4. It's pi cube. And charge of the shell, it's integral 4 pi r square dr, rho B, charge density of the outer shell. And radius is from 1 to, that's Ra to Rb. Ra is 1. So on Rb, rho B is given as 2 k by r. So if you put that, we'll get the charge of the outer shell is 4 pi k Rb square minus 1. So it depends on Rb. So for different cases, different values of Rb are given. Option A, Rb is root 3 by 2. So Rb square is 3 by 2. So from there we'll get the charge in the outer shell as 2 pi k. So total charge is 3 pi k, which is not equal to 0, because for the electric field just outside, it's like a whole thing is made as a point charge in the middle. So only the electric field can become 0 is the volume of the point charge is 0, but the total charge is not 0. So option A is not true. Option B, Rb is 3 by 2. So from there we'll get QB as 4 pi k into Rb square minus 1. Rb square will become 9 by 4 minus 1, that's 5 by 4. So charge in the outer shell is 5 pi k, and potential at the point just outside B is the total charge, that's 5 pi k plus pi k. So 6 pi k by R B, which is 3 by 2, and 1 by 4 epsilon naught. Plus k by epsilon naught. So option B is true. Option C, RB is given as 2. So RB square is 4. So charge in the outer shell is 12 pi k. So total charge is 13 pi k. So it is not equal to 0. So option C is not true. Because option C says total charge is 15 pi k. Option D, RB is 5 by 2. So 5 by 2 square is 25 by 4. So charge in the outer shell B is 21 pi k. So total charge is 22 pi k. So electric field at B plus is just outside B is 1 by 4 epsilon. The total charge as a point charge in the middle, 22 by the distance square. That is 25 by 4. That is 22 by 25 k by epsilon naught. So option D is not true.